We are Group 110 and we are here to present our final project presentation for AI versus wardrobe. I'll walk you through the motivation and then the problem definition. So we know that online shopping, it lacks personalized recommendation and it leads to a poor user experience, and there are a lot of returns because people, they are not able to see how the cloth looks on them before buying it. And we thought that AI can enhance this experience by offering smart virtual try-ons and pattern recommendations for those try-ons. So the problem statement that was developed was that we'll develop a AI-powered fashion recommendation system that will suggest the users outfits based on their user preference and the weather conditions, and integrate a virtual try-on feature that will allow the users to see themselves wearing those different outfits before making a purchase, and improve the accuracy as well as realism of the AI-generated try-ons by leveraging deep learning models such as GANs for better garment fitting.
Data set are the big question data set, which is large scale data set, basically containing images. Then we use impression ML. It consists of grayscale tables of tokens, and it is widely used for classification tasks. And the last one is the user uploaded image. The user can upload this image on a website on our website.
So now I'll walk you through the flowchart of how our application will work. So you will be uploading your image as well as the image of clothes that you want to try on. We will then estimate the pose based on the user's shape, and then we'll try to warp the garment according to the user's pose, and then we'll try to segment that image and try to overlay it on the user's body. It will be clear when we show you some examples going on.
So we had tried many approaches for the cloth trial. So first one was the IOV. It basically means aligning clothing onto a user's image by assigning the indices to vertices on the garment as well as the user's body. Then we had used the thin plate spline transformation. It's basically used to deform the shape of the clothing to match the shape of the user's body. We had also used unit model, TMM and UM, TMM and UM model, which basically means geometric matching module and try-on module. So it expects aligns clothing with the user's body, and DOM is applied to overlay the clothing onto the user's image. However, the best model was the ACGPN model. Creation of GAN is built upon top of the fixed model, which is specifically designed for image translation.
So this is the baseline model architecture that we used. So we had semantic generation module, the cloth warping module, and the content fashion module. Basically, when you upload your clothes, we try to warp it in this module. The semantic generation module estimates the key points of the user's body, and then we try to warp the cloth according to the pose, and then the fusion module overlays it onto the user's body, generating the output.
Benefit of the ECGPN architecture, which we use in our program, that it's a variation of GAN. So it focuses on controlling attributes within the generated content. So since we are focusing on growth, so it controls the attributes within that region. It is built on top of the fixed model, and also there is a special architecture of parsing module, which focuses on improving the accuracy of human parsing.
So this is the output that we received. As you can see, this is the user image. We try to find the key points on the user's image. This is the cloth that is uploaded. We segment that image and warp it according to the user's body and overlay it on their body.
And the architecture that we used in the trial, that is glass necklace theory, is that we fine-tune the delip shift predictor using the iBug 300W dataset. It basically consists of 68 facial landmarks, which represent the key points on the face. And we fine-tune the pre-trained hair cascade classifier, especially the UT face detection for for eye detection, and Nottingham data set for ear detection. And we resize all the positive and negative samples accordingly.
So this is the output of the accessory try-on where you upload your image, the accessory, and you overlay it onto your face, generating a real output.
And for the Herwig trial, we followed the various steps. First was the image segmentation. Then we did the image cropping and transformation. Then fast matching method and the edit was used. So fast matching method is basically used in the mid part.
So this is the Airwick try-on output where you upload your image, the person's hairstyle that you want to copy, and we try to extract the hair and overlay it onto the user's body. We use different evaluation measures. SSIM is a sliding window technique, which is used to compare the mean variance and covariance of the generated and real images. These are the scores. We also use the landmark alignment error to calculate the average Euclidean distance, and these are the results. Now we'll walk you through the web layout.
So web layout, you can upload your own image and then click on the buttons of which triangle you want to try. Suppose we click on the earrings, then we could just upload the left earring and the right earring, and then we can get the output, which can be shared on Instagram, Facebook, and other social media sites, and we can even download.
So these are the references. Thank you. That was our presentation.